So you want to convert decimals into fractions. Well, there's two kinds of decimals. There's terminating, which is on the left, and there's repeating, which is on the right. You'll know the repeating because it has the little repeating sign right on top. So here we go. On the left-hand side, any terminating decimal can be turned into a fraction, which is why we call it rational. And the way we do that is you simply identify the place value of the last number. So this right here is the tenths, hundredths, and thousandths. The last digit is in the thousandths. So we're simply going to make this over 1,000. So we're going to take 3 and 124 over 1,000. Look, we've just proven that this decimal is a rational number because we can turn it into a fraction. Now, we recognize that we probably need to simplify this, so go ahead and simplify if you can. The largest number these both have in common are 4, so I'm going to divide both of those by 4, and I'm going to get 3 and 31 250ths, and that is my mixed number that represents 3.124. Simple. Now, for repeating decimals, there's a little bit more work, but the same general idea is that you just follow a series of steps. The difference here is instead of worrying about place value, because there isn't really a place value when you have an infinite number of digits, it's how many digits are repeating. And what you'll notice in this one is that we have 2 digits that repeat. So if each digit that repeats gets a 10, we have 2 tens. 10 times 10 is 100, so we're going to multiply by 100. Right? So that's the key. Every time you have an additional repeating digit or a unique repeating digit, we would multiply by an additional 10. 2 repeating digits, 10 times 10 is 100. Now, what do we do with that 100? Well, let me show you. First, we want to convert this into a fraction. Well, I don't know what that fraction is, so the first thing I'm going to do is set it equal to a variable so that I can work with it algebraically. The second thing that I'm going to do is I'm going to multiply by that 100 that we were just discussing, right? Different problems will have different values. Now, when multiplying 3.12 repeating times 100, I move my decimal 2 spaces to the right. So I get 312, but I still have 121212 forever. So 0.12 repeating. So it's almost like moving the repeating symbol after the decimal. And that's really the goal here. 100 times x is 100x, nice and simple. And now we're going to do something that is kind of key to the whole problem. We're going to take the original statement that we wrote, 3.12 repeating equals x, and we're going to write it below our product. So notice I'm going to line up my decimal points, 1, 2 repeating, and this is the thing of beauty here. If you see it, your repeating digits, they line up exactly, which means we're going to be able to eliminate them, which is what we want. We bring the x down on the opposite side. Again, notice how that is the same as the original statement. We're going to do some subtraction now, so watch this. 309 is what happens when we subtract on the left. 99x is what happens when we subtract on the right. We're going to do a little dividing by 99 to both sides. And by the way, if you're ever asked to prove that a repeating decimal is a fraction, which is to say prove a repeating decimal is rational, we just did it. Look, the 99s cancel out, and you have 309 divided by 99. Now, it's not simplified and it's an improper fraction, but it's proof, 100% proof, that this original repeating decimal is rational because we can make a fraction out of it with integers on the top and bottom. If your teachers want you to clean it up a little bit, here we go. 99 goes into 309 3 times with 12 remainders. So we do 3 and 12 99ths. And we're probably going to go ahead and simplify that a little bit more. They both have a 3 in common. So we have 3 and 4 33rds equals x. So now not only have we proved that the repeating decimal is rational, but we've also shown what it in fact equals. So good luck converting decimals into fractions.